Chapter 7 is all about probability. So, in this first section, we'll just get an introduction to probability theory. And probability theory just gives us a measure of the likelihood of a certain outcome of an event. So, we've seen probability quite frequently in the real world, in everything from weather to insurance companies use a lot of probability. Sports, if we have a player who has made 80% of all free throws that they take, then we might want that player to shoot the next free throw because the probability is pretty good that they will make the next one. So in our talk about probability, we'll need a couple of terms. So we'll talk about some of the terminology first that we'll be using. An activity or a phenomenon that we're considering is called the experiment. So flipping a coin, picking a number out of a hat, shooting a free throw. Each of those would be called an experiment. And an experiment can produce a variety of results. But the result of our experiment is called the outcome. And we'll repeat it activity a certain number of times. And each time we do that thing, it's called a trial. So if I'm rolling a die, I do it 10 times. Each roll is a trial, or each repetition of the experiment is called a trial. And then we'll measure the likelihood of a certain outcome, and we'll refer to that as the probability. We'll give the probability a number. Generally, experiments involve some chance and the results are random. So there's no pattern that would help us see what the outcome will be. The outcome is just left to chance, like playing the lottery. If they pick your numbers, that's just random, up to chance. We can, however, make decisions based on history and experiments that we have observed and using the probability. So probability deals with random outcomes, but we have some long-term patterns. So over a whole lot of trials, there's predictions that we can make about what will happen in the long term. So I don't know if your next coin flip is going to be heads or tails, but I can tell you if you flip 1,000 coins, what's more likely that you would roll the most or flip the most. One way to measure probability is called empirical probability. The empirical method estimates the probability of an outcome by observing a number of trials and then counting the number of times that the outcome occurs. The relative frequency of an outcome of an experiment is calculated by dividing the number of occurrences of the outcome by the number of trials. So for example, to calculate the relative frequency of flipping heads on a fair coin would be the number of times that I flipped heads divided by the number of times that I flipped the coin. In flipping a coin, there are only two possible outcomes. So we would think that the probability of flipping one or the other, heads versus tails, would be 50%. However, it happens very often that if I flip a coin just twice, then I end up with heads twice or tails twice. And so I don't get, one of each. As we flip more coins, the probability does approach 50%. So in just flipping the coin twice, I may not get 50% heads and 50% tails. But as I flip more and more and more coins, if I flip the coin 1,000,000 times, then probably about half of those will be heads and half of them will be tails. So the law of large numbers says that as we repeat the experiment and we have more and more trials, then the relative frequency is going to get closer to the actual probability. So here's a table of results of an experiment that some people did way long time ago in 1800s. They did a coin tossing experiment and calculated the relative frequency of of flipping heads when they flip the coin. And you can see that the more trials that the person performed, the closer their probability of flipping heads got to 50%. So that's just a demonstration of the law of large numbers. We'll get closer to the actual probability the more trials we perform, the more times we repeat our experiment. All right, in this example, we have a table of some data, and we're going to calculate the relative frequency of a few different outcomes here. So this college has 1,210 students, and the table shows us how many are in each class. If a student is selected at random, so based on no criteria, completely random, eyes closed, picking somebody, we're going to calculate the empirical probability that the student is each one of these classifications. So calculating relative frequency, we're just taking the number of occurrences of the outcome that we're looking for divided by the total number of trials. Okay, so not terrible, fairly simple calculations. The probability that we would pick a freshman, there are 420 freshmen, so 420 possible occurrences of freshmen. And then I'm just going to divide that by the total number of students. So dividing it by 1,210. Now in writing your probability, typically we'll write it as a decimal or a percentage. So you're just doing the top divided by the bottom, which here would give you a 0.35. And to go from decimal to percent, you're just moving the decimal to the right 2 times. So this is equivalent to 35%. You also could just reduce that fraction. All of those would mean the same thing. Notation, we would do P of freshman. So that's the probability of picking a freshman. And that is equal to 0.35 or 35%. So we do the same thing for sophomores. You're just taking the number of sophomores and dividing it by the total number of students. So there are 315 sophomores divided by 1,210 total students. Doing the top divided by the bottom is going to give a 0.26 or 26%. So probability that the student is a sophomore equals 0.26. For junior, there's 260 of them, so we're dividing 260 by 1,210. And that's going to give us 0.21. So that's the probability that the student is a junior. And same thing for senior. There's 215 of them, so we're going to divide 215 by 1,210. And this one gives me a 0.18, which is 18%. And notice here that all of these numbers for part A, B, C, and D, if I add them all together, I get 1. The probability that a student that I choose would be a freshman, a sophomore, a junior, or a senior has to be 100%. If I'm picking somebody, it's going to be one of those. So all of your probabilities together need to add up to 1 or 100%. Okay, in part E, we need to get the probability that the student is a freshman or a sophomore. And doing that, we're just going to take the number of freshmen and the number of sophomores and add them together and divide that by 1,210. So we're taking the probability of the student being a freshman and the probability that the student is a sophomore and adding those together. Notice that this is the same as 420 plus 315 all over 1,210, so it doesn't matter if you add them together first. It is the same operation, but since we already calculated these two as decimals, I know that 420 out of 1,210 is 0.35. And 315 out of 1,210 is 0.26. So I can add those together and I'm going to get 0.61. That is the probability that we get a freshman or a sophomore. All right, another definition here, a sample space instead of all the possible outcomes of an experiment. And each element of the sample space is called a sample point or a simple outcome. So, for example, if the experiment is tossing a coin, the sample space would be heads and tails. A set that includes heads and tails, because that's all the possible outcomes from flipping a coin. If I flipping the coin twice, so if my experiment is flipping the coin twice, then the possible outcomes from that would be that I get two heads, I get two tails, I get a heads and then a tails, or a tails and then a heads. So each of those would make up the sample space. All right, there are a couple of properties of probability that we'll need to use to help us solve some problems. So here, if we've got this sample space, and we have all of these simple outcomes, so like E1, E2, and so on, are simple outcomes, so possible outcomes of our experiment. There are a couple of properties that we know about this space. The first one is that each simple outcome is assigned a probability, and we'll use the notation P of that outcome, just like we did in that last example. The probability of an event is going to come from the sum of the probabilities of all the simple outcomes that make up that event. So like when we did the probability of choosing a freshman or a sophomore, and we took the probability of choosing a freshman and added it to the probability of choosing a sophomore. So that's just what this property says. The third property says that a probability is going to be a number between 0 and 1, including 0 and 1. So probability is not going to be negative, and it's not going to be anything greater than 1. Probability can't go over 100%, or we can't have a negative 42% probability that something's going to happen. So we've got to stay between 0 and 1, between 0% and 100%. And I also mentioned this in that last example, that the sum of the probabilities of all simple events in the sample space need to add up to 1. So here's just one more short example for this section. We got a sample space that includes A, B, and C. So those are our possible outcomes. And they give us the probability for A and for B. And then they ask us what's the probability of C. So for this, we will be using this last property, that I know the sum of all the probabilities needs to equal 1. So probability of A plus the probability of B plus the probability of C need to equal 1. And I know the probability of A is 0.2, probability of B is 0.4, and then I can use that to find the probability of C. So I really just need to subtract 0.2 and 0.4 from 1. So together they make 0.6. And then I'm going to subtract. So probability of C is 1 minus the probability of everything else. And that is just equal to 0.4.